In this module, you will be introduced to the Automatic Flight Control System, or AFCS. We will start out with a brief system description. After that, we will look at the individual components of the system, starting with the autopilot and yaw damper systems. Next, we will look at the flight director system. Moving on, we will look at the different AFCS vertical and lateral modes. Finally, we will look at the AFCS altitude alert function. The ATR 72-600 is equipped with an autopilot system that can control the aircraft about all three axes. In addition to autopilot functions, the AFCS also provides yaw dampening functions, flight director guidance, and altitude alerts. The AFCS consists of two core avionics cabinets, or CACs, a flight guidance and control panel, or FGCP, two index control panels, or ICPs, two flight mode annunciators, or FMAs, three servo actuators, and two power trim boxes. CAC-1 controls the autopilot functions, and CAC-2 monitors the autopilot functions. The CACs communicate with the 5 display units, as well as aircraft systems, through data buses. The CACs host the Automatic Flight Control application, the Flight Warning application, or FWA, the Data Concentration application, or DCA, and the Centralized Maintenance application, or CMA. The CACs receive data from the two air data computers, or ADCs, the two attitude and heading reference systems, or AHRS, the radio altimeter, navigation systems 1 and 2, the flight management system, or FMS, as well as other sensors. Based on the data supplied, the CAC generates commands which are then fed to the flight director system and the autopilot servos. Flight director commands are also displayed on the primary flight display, or PFD. The flight guidance and control panel, or FGCP, is used to engage or disengage the autopilot. It is also used to engage the yaw damper, as well as to select the desired operating mode of the flight director or autopilot system. The FGCP is located on the glare shield. The Index Control Panel, or ICP, is used to select the airspeed control mode, set the desired airspeed, set the barometric reference, and select either decision heights or minimum descent altitude. A Flight Mode Annunciator, or FMA, is located at the top of each PFD. The AFCS uses 3 servo actuators to control the aircraft. These consist of an electric motor and a clutch assembly that moves the respective flight control surface. The pitch and yaw actuators are located in the aft portion of the aircraft. The roll servo actuators are located on the aft side of the wing box. The control for the servos is powered by the DC standby bus. Autopilot inputs to the roll axis are made through a roll servo actuator, which uses a cable and drum assembly to control the roll axis. Inputs made by the autopilot are reflected on the control wheels. Autopilot inputs to the pitch axis are made through a similar servo actuator, which drives a cable and drum assembly. The autopilot makes trim inputs in the pitch axis only, and they are reflected on the control column. The autopilot does not control the trim actuators for the aileron. This is controlled by the pilot in order to maintain coordinated flight, as well as to minimize the load on the servo actuators. A yaw servo actuator also uses a cable and drum assembly to make inputs to the yaw axis. Two power trim boxes provide an interface between the CACs and the pitch and yaw trim systems. The yaw damper provides yaw damping and turn coordination functions. CAC1 uses the autopilot yaw actuator to transmit the necessary yaw damping and turn coordination commands. The autopilot is engaged by pressing the AP push button on the FGCP. When the autopilot is engaged, the yaw damper is automatically engaged as well. Engagement of the autopilot and yaw damper is indicated by the illumination of the arrows on each side of the AP and YD push buttons. If the autopilot is engaged, it can be disengaged by pressing the AP push button a second time. However, this action will only disengage the autopilot and the yaw damper will remain engaged. The autopilot can also be disengaged with the red autopilot quick disconnect button on the control wheel. The yaw damper can be engaged independently of the autopilot by means of the YD push button. The two arrows on the side of the push button illuminate when the yaw damper is engaged. If the autopilot is engaged, it will automatically disengage if the yaw damper is disengaged by pressing the YD push button. Once the autopilot is engaged, it will control the aircraft through the three servo actuators. In addition, the pitch auto trim and yaw auto trim functions are activated. If no vertical and lateral modes are selected on the FGCP, the autopilot will engage in the basic mode. The basic vertical mode is pitch hold, in which the autopilot will maintain the pitch that existed at the time of engagement. The basic lateral mode is either wing level, heading hold, or roll hold, depending on the conditions at engagement. In wing level mode, the autopilot will level the wings and maintain level wings. In heading hold mode, the autopilot will maintain the heading that existed at the time of engagement. In roll hold mode, the autopilot will maintain the bank angle that existed at the time of engagement. If the autopilot is engaged when a vertical and/or lateral flight director mode is active, the autopilot will immediately maneuver to follow the active commands. If the autopilot is engaged when a vertical and/or lateral flight director mode is armed, the autopilot will remain in the basic mode until the flight director modes are active, at which time the autopilot will immediately maneuver to follow the active commands. It should be noted that if a lateral mode is active and no vertical mode is selected, the autopilot will engage in the active lateral mode, but will remain in the basic vertical mode. The same holds true if a vertical mode is active and no lateral mode is selected. The autopilot will engage in the active vertical mode, but will remain in the basic lateral mode. The lateral and vertical modes are selected on the FGCP. The vertical modes are selected by the three vertical mode push buttons labeled, from top to bottom, IAS, VS, and ALT. The vertical speed mode is selected by pressing the VS push button. Once selected, the vertical speed can be changed by means of the pitch wheel, located to the left of the three vertical mode push buttons. The lateral modes are selected by the five lateral mode push buttons, located to the left of the pitch wheel. These push buttons are labeled, from top to bottom, heading, nav, approach, back course, and standby. The maximum bank angle used during turns varies automatically. When the airspeed is below the minimum speed for high bank, or if the radio altitude is less than 1,000 feet, the system will limit the bank angle to 15 degrees. This will be indicated by the LO label on the FMA. Otherwise, the maximum bank angle is 27 degrees. The autopilot can be disengaged either manually or automatically. The autopilot can be manually disengaged by using one of the autopilot quick disconnect push buttons on the control wheels. Using pitch trim, either normal or standby pitch trim. Pressing the AP push button on the FGCP. Pressing the YD push button on the FGCP. Using one of the go-around buttons on the power levers. Or by applying a force on either of the rudder pedals or the control column. If the autopilot is manually disengaged, the yaw damper will remain engaged, unless the autopilot is disengaged by using the YD push button, or by applying a force on either set of rudder pedals. A manual disengagement of the autopilot is indicated by the red autopilot disengaged message on the FMA, and a cavalry charge oral alert. In addition, the two green arrows on both sides of the AP push button will extinguish. If the yaw damper has also disengaged, the two green arrows on both sides of the YD push button will extinguish as well. The message on the FMA will be different. It will display a red autopilot yaw damper disengaged message instead. The autopilot disengagement warnings and message can be cleared by pressing the autopilot quick disconnect button on either control wheel. If engaged, the autopilot will automatically disengage in the event one of the engagement conditions for the autopilot or yaw damper no longer exists. The stall warning threshold has been reached. There is an ADC or AHRS disagreement. There is a failure of one ADC or one AHRS. Or there is a mismatch between the two pitch trim commands. An autopilot pitch trim fail, pitch mistrim, aileron mistrim, rudder mistrim, or yaw auto trim fail message on the FMA indicates a system failure. In this case, the crew's only option is to disengage the autopilot and hand fly the aircraft for the remainder of the flight. If a pitch trim asymmetry message appears on the engine and warning display, or EWD, the autopilot will automatically disengage and cannot be re-engaged. If the autopilot or yaw damper disengage due to a fault, the affected system can be re-engaged by pressing the autopilot quick disconnect push button. This will clear the FMA messages and the autopilot computer will reset the system, allowing the autopilot or yaw damper to be re-engaged. However, if the cause of the disengagement still exists, the autopilot or yaw damper will disengage again. The touch control steering, or TCS mode, allows the pilots to take control of the aircraft while the autopilot is engaged. In the TCS mode, the pilot can manually change the aircraft's attitude, altitude, vertical speed, and/or airspeed, without disengaging the autopilot. The TCS mode is entered while the autopilot is engaged, by pressing and holding the TCS push button on the outboard horn of either control wheel. If the TCS push button is pressed while the autopilot is engaged in the basic mode, the pilot can maneuver the aircraft and reset the autopilot's pitch and roll references. When the TCS push button is released, the autopilot will use the references existing at the time the button was released. There are some limitations to this reference reset. The pitch angle must be within +15 and -11 degrees at the time the TCS push button is released. If the pitch exceeds these values at the time of the push button release, The autopilot will automatically reset the pitch reference to the closest value. If the aircraft's roll angle at the time the TCS push button is released is less than 6 degrees, the autopilot will automatically return to wings level. If the aircraft's roll angle is between 6 and 35 degrees at the time the TCS push button is released, the autopilot will use the new roll angle as the reference. If the aircraft's roll angle is above 35 degrees at the time the TCS push button is released, the autopilot will automatically roll the aircraft back to 35 degrees and maintain that roll angle. If the autopilot is in the vertical speed hold or pitch hold mode when the TCS push button is pressed, the pilot will be able to resynchronize the air data command references without disengaging the mode. The commands from the AFCS can be displayed on the PFD through flight director bars. This part of the AFCS system is called the flight director system. The flight director bars consist of a vertical bar for the lateral mode and a horizontal bar for the vertical mode. The flight director bars command pitch and roll based on the active mode. If no vertical mode is active, the pitch command bar will command pitch hold. If no lateral mode is active, the roll command bar will command heading hold, roll hold, or wing level, depending on the situation. The command bars can be removed from the PFD by using the FD push button on either side of the FGCP. The left push button controls the command bars on the captain's PFD, and the right push button controls the command bars on the first officer's PFD. The flight director vertical modes consist of altitude select, altitude, vertical speed, indicated airspeed, and VNAV, if the aircraft is VNAV equipped. The flight director lateral modes consist of heading select, nav, and back course. These modes are the same modes as the autopilot modes. The flight director system also has two combined modes, where lateral and vertical guidance is integrated. These are the ILS approach and go-around modes. The modes are selected on the FGCP. It should be noted that modes selected on this panel apply to both the autopilot, if it is engaged, and the flight director. There are two modes that are not selectable through the FGCP. These modes are the altitude select and the go-around modes. Altitude select is automatically armed, and is both an autopilot and flight director mode. The go-around mode is armed by pressing one of the go-around push buttons on the power levers. The go-around mode is a flight director mode only, and is not applicable to autopilot operations. After pushing the go-around button, the lateral mode bars of the flight director will command the present heading of the aircraft, and the vertical mode bars will command a safe pitch attitude, based on the flap setting and single engine performance. During a go-around, the FMA displays GA as the vertical mode, and heading hold as the lateral mode. Some modes require an arming phase and a capture phase before becoming the active mode. An example would be in the case where a crew is flying a heading to intercept an ILS. First, the crew would arm the ILS approach mode by pressing the approach push button. This arms the system to capture the localizer and glide slope. Localizer and glide slope would appear as cyan armed modes, below the green active modes in the FMA. At localizer capture, localizer would become the active lateral mode. At glide slope capture, glide slope would become the active vertical mode. The four columns of the FMA provide annunciations for icing status information, lateral modes, vertical modes, and engagement status of the autopilot. Each column has 3 rows. Armed lateral and vertical modes are displayed in the second row of the second and third columns, respectively. These armed modes are displayed in cyan. During a capture, a previously armed mode moves to the first row, and is displayed in green with an asterisk, inside a green box. Once captured, the asterisk is removed, and the green box remains in view for 7 seconds. After that period, the green box is removed, to indicate that the new mode is in the hold mode. Messages are displayed on the third row of the FMA. In addition to icing information, the first column will also display any trim status messages in the third row. These messages are displayed in reverse video, and flash for 7 seconds when they first appear. After that period, the message stops flashing, but remains in view. There are no oral alerts associated with the messages that can appear in this position. The right-hand side of row 3 in column 2 indicates the operational category for the approach. ILS approach categories include Cat 1 and Cat 2. If the aircraft is equipped for localizer performance with vertical guidance, LPV can also appear in this position. If the aircraft is equipped for required navigation performance with authorization required, RNPAR can also appear in this position. Row 3 in column 3 of the FMA shows messages associated with unexpected mode changes, or problems with navigation parameters. These messages flash for 7 seconds when they first appear. 2 more messages can appear on this line. The green steep approach message is displayed when the steep approach mode is selected. A flashing amber AFCS test message flashes when maintenance is testing the AFCS. Column 4 of the FMA provides a lot of information regarding the autopilot and flight director system. On row 1, the first subcolumn shows the AP label when the autopilot and yaw damper are engaged. FD in the second subcolumn indicates that the flight director bars are displayed on the PFD. The third subcolumn of row 1 indicates how the autopilot flight director system is coupled. When the autopilot flight director is coupled to one side, the autopilot flight director system will use the associated autopilot yaw damper computer. The direction of the coupling is indicated by an arrow. Coupling is selected using the CPL push button on the FGCP. At power up, the system is automatically coupled to the captain's side. Click on the CPL button to couple to the first officer's side. In addition to the green arrow in the FMA, the arrow adjacent to the CPL push button will also indicate the direction of the coupling. A dual coupling mode occurs automatically during a Category 2 ILS approach. This dual coupling will be indicated by the illumination of both arrows on either side of the CPL push button on the FGCP, and the dual message on the FMA. Dual coupling occurs automatically after localizer and glide slope capture, provided both nav receivers are tuned to the same ILS frequency, the inbound course is the same on both sides, and the radio altitude is below 1,200 feet. The CACs then use the average value from both receivers to determine the guidance commands to fly the approach. If the approach mode is cancelled, the flight director will remain coupled to the side selected at the time the dual coupling occurred. In the event an excessive deviation is detected during a dual approach, or if Category 2 engagement conditions are lost, the crew will be alerted by the red excess deviation message on the FMA. This message flashes in red reverse video for 7 seconds. It then turns amber. All armed, captured, and active autopilot and flight director modes can be cancelled by pressing the standby push button on the FGCP. Pressing the push button reverts the autopilot and flight director to basic modes. The altitude select mode is automatically armed when the aircraft is climbing or descending towards a selected altitude. The selected altitude is set by rotating the altitude select knob on the FGCP. The selected altitude is then displayed above the PFD altitude indicator. The altitude select mode goes through 3 distinct phases. These phases are the armed phase, the capture phase, and the hold phase. In the altitude select mode, the crew can use vertical speed hold, IAS hold, or pitch hold to perform the climb or descent. Arming of the altitude select mode is indicated by a cyan altitude select label on row 2 of the third column of the FMA. When the aircraft approaches the selected altitude, the AFCS will transition to the altitude capture phase. When this occurs, the mode used to fly to the selected altitude is cancelled. The AFCS will provide guidance to capture the selected altitude. The altitude capture phase is indicated by the appearance of the green ALT label on line 1. This label is boxed. The asterisk indicates that the mode is capturing. The autopilot will automatically default to the pitch hold mode if the selected altitude is changed during the capture phase. Therefore, the AFCS mode used to capture the new altitude must be reselected on the AFCS control panel. An amber ALT off label is displayed in the FMA when the selected altitude is changed. Once the altitude has been captured, the altitude hold mode will engage, and the altitude select capture mode will automatically disengage. The altitude hold mode is indicated by the green ALT label on the FMA. It should be noted that the altitude select and the altitude hold modes are automatically cancelled at glide slope capture if the approach mode is armed. The altitude hold mode can be engaged by pressing the ALT push button on the FGCP. Selection of this mode automatically cancels all active flight director vertical modes. When the altitude hold mode is selected, the aircraft will round out the climb or descent to return, and hold the altitude existing at the time the altitude hold mode was selected. In addition, the selected altitude is set on the altitude indicator on the PFD. The altitude hold mode is indicated by a green ALT label on the FMA. The aircraft can be placed in the vertical speed hold mode by pressing the VS push button on the FGCP. This action cancels any other active flight director vertical modes. The AFCS will provide the guidance commands required to maintain the vertical speed existing at the time the VS push button was pressed. Engagement of the vertical speed mode is indicated by a green VS label on the FMA. The reference vertical speed can be changed by rotating the pitch wheel on the FGCP. Rotating the wheel will maintain the aircraft in the vertical speed hold mode while changing the vertical speed reference value. The selected vertical speed is indicated by a cyan bug on the vertical speed scale of the PFD. The touch control steering or TCS system can also be used in the vertical speed hold mode to change the reference vertical speed. Any other vertical mode can be armed while operating in the vertical speed hold mode. Once the new mode is captured, the vertical speed hold mode will automatically disengage. The indicated airspeed hold mode is selected by pressing the IAS push button on the AFCS control panel. Action on this push button will disengage the active vertical mode. Once the IAS mode is selected, the AFCS will provide guidance to maintain the indicated airspeed existing at the time the IAS push button was pressed. The airspeed is indicated on the PFD airspeed tape by a cyan bug. Initially, a green boxed IAS label appears on the first line of the third column of the FMA. The box is removed after 7 seconds. The airspeed to hold can be set manually by the crew or automatically by the FMS. This is controlled by the speed target control push button labeled Auto Manual on the ICP. When the speed is automatically controlled by the FMS, the speed bug on the PFD is displayed in magenta. Click on the Auto Manual push button to manually control the airspeed. When manual is selected, the speed bug on the PFD is displayed in cyan. The speed is increased or decreased by rotating the adjacent speed knob. Any other vertical mode can be armed while operating in the IAS hold mode. Once the new vertical mode is captured, the IAS hold mode will automatically disengage. Heading selection is made by rotating the heading rotary knob. The heading select mode is selected by pressing the heading push button on the FGCP. This action will automatically override any active lateral mode. Click on the heading push button to continue. When the heading select mode is active, the FMA displays a green boxed heading select label. The box disappears after 7 seconds. If the heading to follow is more than 180 degrees from the aircraft heading existing at the time the heading select mode is engaged, the AFCS will command to turn in the shortest direction. However, heading changes made after the heading select mode is engaged will cause the AFCS to command to turn in the direction of the heading change. The bank angle used during the turn depends on the bank angle mode. If you recall, a maximum of 15 degrees is used if the airspeed is below the minimum airspeed for high bank, or the radio altitude is below 1,000 feet. Otherwise, a maximum bank angle of 27 degrees is used. A restricted bank angle is indicated by the green LO label on the FMA. Any other lateral mode can be selected while operating in the heading select mode. The capture of any armed lateral mode will automatically disengage the heading select mode. The navigation mode is armed by pressing the navigation push button on the FGCP. This arms the AFCS system to capture the selected navigation source. This navigation source is displayed on the EHSI. The possible navigation sources are VOR, Localizer, or LNAV. Click on the navigation push button to arm the VOR. If VOR navigation is selected, a cyan VOR label is displayed on row 2 of the second column of the FMA. This indicates that the VOR mode is armed. The heading select mode is used to capture the desired navigation source. At a certain point, the AFCS will transition to the VOR capture mode. This will be indicated by a green boxed VOR label on row 1 of the FMA. The asterisk indicates that the VOR mode is capturing. The box is removed 7 seconds after the VOR capture label was displayed, even if the aircraft is still capturing the VOR. Once the aircraft is on the selected VOR track, the asterisk is removed, and the VOR label is boxed again for 7 seconds. When the aircraft approaches the VOR station, it will enter the zone of confusion where VOR station signals are unreliable. In this case, the AFCS will enter the overstation mode. In this mode, the AFCS will provide steering commands based on heading only. After station passage, the AFCS will recapture the selected VOR course. The localizer navigation mode is similar to the VOR mode, except that there is no overstation mode. The messages are replaced with a localizer message. The AFCS can be used to fly a back-course localizer approach. The back course is set up just like a localizer approach, except that the BC push button must be pressed. Selection of the back course mode automatically inhibits the glide slope mode. A back course is set up by dialing in the front course value. The ILS approach and go-around modes are common modes. The ILS approach mode is armed by pressing the approach push button on the FGCP. The go-around mode is entered by pressing the go-around button on either power lever. Pressing the approach push button on the FGCP arms both the localizer and glide slope modes, provided an ILS frequency is selected on the coupled navigation receiver. When the approach mode is armed, localizer and glide slope will be displayed on row 2 of columns 2 and 3 of the FMA. This indicates that both these modes are armed. When the approach is armed, the crew can use any vertical mode and the heading select or heading hold mode to capture the localizer and glide slope. Capture of the localizer will automatically cancel the selected lateral mode. A green boxed localizer label is displayed on row 1 of the FMA. The asterisk indicates that the mode is armed. Once the AFCS is tracking the localizer, the asterisk is removed from the label. As with the other cases, the green box disappears after 7 seconds. The ILS approach mode is called a common mode, since glide slope capture is not possible until the localizer has been captured. The capture of the glide slope will automatically disengage the vertical mode used to capture the glide slope. Once the glide slope is captured, the green boxed GS label is displayed in row 1 of column 3. The asterisk indicates that the mode is capturing. Tracking of the glide slope by the AFCS is indicated by the removal of the asterisk. Activation of the go-around mode will cancel out all active or armed flight director modes. Pressing the go-around button on either power lever will automatically disengage the autopilot, and the flight director will command a minimum safe pitch. In addition, the flight director will provide commands to maintain the heading existing at the time the go-around button was pressed. It is important that you understand that the go-around mode is a flight director mode only, and cannot be flown using the autopilot. When the go-around mode is engaged, the FMA will display a heading hold and go-around label on row 1 of columns 2 and 3 of the FMA, respectively. Note that the green box will appear around both labels to indicate the mode change. The box is removed after 7 seconds. The go-around mode is cancelled by the selection of a different vertical mode, engagement of the TCS system, pushing the standby push button on the FGCP, or by engaging the autopilot. The AFCS provides an altitude alerting system to alert the crew that the aircraft is approaching or departing a selected altitude. The alert consists of a visual and oral alert. The visual alert consists of a flashing yellow box around the altitude readout on the PFD. The oral alert consists of a C chord tone. The amber altitude box flashes when the aircraft is within 1,000 to 250 feet of the selected altitude. If you recall, the desired altitude is selected by the Altitude Select knob on the FGCP. The alert tone sounds when the aircraft enters the 1,000-foot point or exits the 250-foot point. This concludes the AFCS module.